Hey guys, welcome back to my implementation series. So in the last two videos, I had gone over the official FastLio 2 implementation and the baseline implementation. In this video, I'm going to focus on some custom algorithms that have been developed for the rover. So one is the scan to map algorithm, and the other is the upgraded cost map. So in the scan to map algorithm, I'm using scan to map for publishing odometry for nav2, and in the upgraded cost map, I'm using a processed version of the 3D point cloud for the local cost map and collision monitor in nav2, as opposed to the 2D projection that I had on my scan from LiveVox topic from earlier modules. So let's start with the scan to map primary odometry. So we'll start with what's happening on the Jetson because that's where most of the changes are. Now, this initial launch is from the LiveVox ROS driver, which we've seen before. So I won't go over that. So let's go over this launch file. So this is the main launch file for scan to map odometry. So let's go and find that launch file. And in that launch file, everything is kind of similar to what we have before. We have this FastLive preprocess module to publish, the custom points preprocessed and custom points for nav2 topics. We have this LiveVox Cloud to Scan node that does the projection. And once we add the upgraded cost map, this projection will only be used for AMCL. The local cost map and collision monitor will actually use the processed version of the point cloud, which is the obstacle cloud, which is published on this obstacle cloud topic, right? And we'll get to that. But the main node that's different here is custom scan to map ODA, right? So let's look at this custom scan to map package. So under source, you'll see custom scan to map ODOM, and under that, you'll have the source folder, of course, and we can look at custom scan to map node, right? This is the main file. So over here, you'll see cloud callback, right? Which is the callback for the custom points preprocess topic. So if you remember from the earlier video, I'd mentioned that the Lio preprocess module is going to publish custom points preprocessed for future odometry modules, right? And scan to map is consuming that. So if we go to the configs for scan to map YAML under config, we'll see the input topic is custom points preprocessed, right? So now under scan to map node, so this is the callback for custom points preprocessed. So whenever that point cloud is kind of published, this method runs. And what this method is doing is it's essentially running the scan to map optimization algorithm, right? So just to give you a quick summary of this algorithm, you can read the details online, but just a quick summary. Essentially, what I'm doing here is maintaining a local map, and between LiveVox scans, I'm using the IMU data to guess the initial state for the robot pose on a given LiveVox scan. And then based on the point cloud I get from the current scan, I'm trying to find the nearest neighbors in my local map, right? And those nearest neighbors create a local plane, and I'm trying to get the orthogonal distance between essentially a point in my point cloud to this local plane. And I want to minimize that distance. I want to find the pose on my rover that minimizes that distance. It's a very high level kind of overview of what scan to map does. I mean, as I said, there's many details here that you should probably go and read online, but when you look at the code, I want you to focus on this particular method, and specifically down, if you move down, you will see the optimizer.optimize call. So this is where the optimization is happening. So this is where the pose is actually being estimated by minimizing those residuals to the local planes, right? That are, of course, those local planes are being created by the nearest neighbors in the local map that's being maintained, right? So first, you should probably just run through this cloud callback, and then I would go into the scan to map optimizer file where the optimization is actually happening, specifically the optimize function here where it's happening, right? And this is again where the pose is being estimated for the rover for every LiDAR scan. And then I would also focus on the local map and the local map manager. So the local map is being maintained for the rover, right? And this is how we're finding nearest points for a rover. We're ensuring that we crop around the rover so that our map doesn't get very large. So there's a good amount of map management happening here as well. So I would encourage you to kind of go through this local map.cpp file as well to see the different functions over here. We're cropping around our rover, we're downsampling. So all of this is happening, and we're using a KD tree here to actually find the nearest neighbors, right? So yeah, so this is what's happening for the local map. So basically the main things you should focus on are scan to map node, cloud callback, the main optimization for scan to map, which is under scan to map optimizer and the optimize function in that, and the local map to see how local map management is happening, how the KD tree is being used to find nearest neighbors, how we're cropping around the rover to make sure we contain our local map so that it doesn't blow up to have too many points because then search will become inefficient, right? So that is what the scan-to-map node is doing in a nutshell. And then based on the pose that we estimate from the scan-to-map algorithm, we're publishing odometry, right? So there is a publish odometry call down here where we publish to the nav2 odom topic for the nav2 stack. All right. Let's talk about point 8, where we'll go into the upgraded cost map, right? So over here, we're essentially, the goal is to use the obstacle cloud topic, which is essentially the 3D point cloud for the local cost map and the collision monitor, rather than the 2D projection of the 3D point cloud, right? That's the idea for point 8, right? So for point 8, mainly, let's look at this cost map projection launch. So there's two versions of the cost map projection launch, point 8 and point 9, right? So I'll just, the difference is pretty minimal. So the idea is in point 8, we have cost map projection launch dot .py over here, and you can see it's using the FastLIO2 implementation along with the upgraded cost map, which is coming from this custom LiveVox cost map projection package, right? But the scan to map cost map projection launch is simply using the custom LiveVox cost map projection package along with the scan to map odometry that I just discussed, right? So this is using all custom algorithms. So scan to map is also custom. The cost map projection is custom. There's no official FastLIO2 implementation in here, right? So the main thing is we want to focus on this node right here, the custom LiveVox cost map projection, right? So under custom LiveVox cost map projection, this package, we'll see the main node, which is LiveVox cost map projection node.cpp. So let's go there. And in here, under cloud callback, so the input topic for this, let me just show you in the config, the input topic is custom points preprocessed, right? So that's coming from that preprocessed package. So custom points preprocessed, and the output is the custom obstacle cloud, right? So in LiveVox cost map projection node, we have this cloud callback, which takes in custom points preprocessed. And the main part of this that you should kind of focus on is filter obstacle cloud. So we're doing some minor processing on top of the obstacle cloud, right? So if we go there, there's just checking the points are finite, filtering out based on the min and max ranges and heights and so on, and publishing, right? So once we do that, we essentially publish this obstacle cloud. And we publish it to this customs obstacle cloud topic, which will be used in our local cost map and collision monitor. So if you look at the README, right? So if we look at the README, we will kind of see that between point 7 and point 8, the difference is on the Pi, we have here we have the nav2 main launch, our old launch file, and here we have the cost map launch, right? So in the cost map launch, let's just check, what is different. So if we go to our Pi FastLIO projection, cost map projection nav2, we have a different config file, right? So if we look at that config file, we see that for the local cost map, so local cost map, right here, we're using the custom obstacle cloud, right? Over here, right? For the obstacle layer, we're using the custom obstacle cloud, and for collision monitor, we are using the custom obstacle cloud as well, right? So instead of the 2D projection, we're using that obstacle cloud. This is why this is the upgraded cost map mode. Now, so basically, those are the changes that are being made here. Now, to launch with everything that we discussed, right? We would want to launch, we would essentially want to launch point 0.9. So that would be scan to map odometry with the upgraded cost map, right? So that's the scan to map cost map projection.launch. So now let me show you how the entire run happens and what are the important topics that are being published in this mode. All right, so let's see what happens when we actually run this particular mode that we've been discussing. So we've been through the code, 4.7, 8, and 9. And now I'll show you kind of what happens when you run it, right? I'm running point 0.9 here because it has the scan to map odometry and the upgraded cost map in one launch file. So I'm essentially, what I did was in one terminal, I kicked off this LiveVox ROS driver, um, launch, and in the other terminal, I kicked off point 0.9, so the scan to map cost map projection launch. And as you can see over here, the scan to map algorithm is running, converging, and if we look at the topic list, we're getting data that's being published on nav2 ODOM by the scan to map algorithm. So that's an important topic. So you can see that's over there, and we can quickly echo it and see odometry being published on that topic. So over here, the odometry is being published, and this is coming directly from the scan to map optimization algorithm. And then we also have, if we go back to the topic list, right, we also have this obstacle cloud. This obstacle cloud is being published by the upgraded cost map for the local cost map and collision monitor, right? So let's just echo that. All right, so this is the obstacle cloud that's being published. All right, so basically that's what's happening for this particular mode. Just one point before I close the video is point 12 here is a scan-to-scan ICP shadow mode. So I'm not going to go into detail on this file, so I'll just quickly kind of review it because this hasn't been integrated with nav2 because scan-to-scan ICP is a much more rudimentary version of scan-to-map ICP. So I decided to just integrate scan-to-map ICP and keep this as a debug mode. But if you look at this particular launch file, there is at the end this custom ICP ODOM node. So we can go to custom ICP ODOM. And the main file, if you want to review this algorithm, you can go to icpodomnode.cpp and you can look at cloud callback. So as I said, it's a more rudimentary version of scan to map ICP. But what it does is if we go up to the topics, it publishes on this custom ICP ODOM. So if you're interested in kind of seeing how it works, you can run this in shadow mode and you can run the mapping node mapping mode on the Pi, and while driving around the rover, you can kind of see how this topic is changing, how odometry is updating. But I didn't integrate it with nav2 for real-time kind of autonomous navigation because it's not as precise, it's not as accurate as scan to map. But this debug mode exists. It's point number 12 in the read, right? But so you can go over that if you want. Okay, so that's all for this video.